Welcome back to Minute Micro Macro. Today we're thinking about, is demand proportional? Hit pause and have a go at this do now question. Draw a diagram showing the demand for cars. What would be the effect of a decrease in population on the market for cars? Show that effect in the diagram, and then write a chain of reasoning explain step by step what has happened. Okay, let's see how you got on. First of all, we're going to use a straight edge to draw our axes. We've got price on the y-axis, and we've got quantity on the x-axis. We're then going to draw demand sloping downwards. I'm going to label it D1. This is going to be the demand for my market of cars. If the population falls, there'll be fewer people to sell to, and so demand will fall. We're going to show that as a shift to the left because quantity is measured on that x-axis. So we're drawing our D2 curve and showing a shift to the left. Your objectives from the lesson today are to understand price elasticity of demand, be able to use the formula, interpret numerical values, to model perfectly and relatively price elastic and inelastic demand, and to recall the factors that influence elasticity. We're going to dive straight into example 1. So we're thinking about the demand for brand A of basmati rice. So we're thinking about a good that I can easily substitute for another brand. They're relatively homogeneous goods. So I'm starting at a price of 100 pennies, so that's £1, and I've got a quantity demanded of 500 units. We're going to see an increase in price, which is going to cause a contraction along demand. So we're going to put our price now 120 pence, so £1.20, and we're going to see a new quantity demanded 100 units. So this lesson is all about proportionality. So we're thinking about the percentage change in price. That has been an increase in price of 20%. And thinking about proportionality in terms of quantity, that's been a decrease of 500 down to 100. So that's an 80% decrease in quantity demanded. And so what we can say is the change in quantity is more than proportional than the change in price, which happens to be the definition of elasticity. Make sure you get the definition written down. Another key note to have written down is how you work out whether a good is elastic or inelastic. The calculation is that you take the percentage change in quantity demanded and divide it by the percentage change in price. If you get a PED value greater than 1, it means your good is elastic. You might have noticed the absolute symbols around PED. That means you ignore the symbol in front of the number. So if you get a negative number, which you will with PED, you can discard that. If the absolute value is greater than 1, you have an elastic good, which does make sense. If the quantity demanded was more than proportional than the change in price, the number in the numerator is going to be greater than the number in the denominator, and so you're going to get an answer that is bigger than 1. Another key piece of information that you absolutely have to note down is that when you see an increase in price for a good that is elastic, you are expecting to see a fall in total revenue. You can see here that revenue is calculated by doing price times quantity. And you know that the area of a rectangle is base times height. So the area of those rectangles represents the total revenue. We can see that the first rectangle was much bigger than the second rectangle, and so total revenue has fallen. But we can also see that the area of the loss of total revenue is much larger than the area of the gain. So when price rises for an elastic good, we expect to see a fall in total revenue. So what are the factors that affect the price elasticity of demand? Well, I've already alluded to the fact that brand A of basmati rice was going to have an elastic PED. And we thought that because it's quite a homogeneous good and there's lots of substitutes. So if the price of one brand of rice went up, you would likely switch your consumption from one good to another. And that's because there are lots of substitutes. The more substitutes there are for a good, the more elastic the PED will be. The greater the proportion of income, the more elastic the good will be. The more luxurious a product is, the more elastic the good will be. And the inverse being, if it is a necessity, it is likely to have an inelastic demand. Similarly, if a good is addictive, you would imagine it would have an inelastic demand. You can imagine that if a price was to rise for an addictive good, the fall in quantity demanded would be less than proportional. The final factor that will affect the price elasticity of demand is time. And now this is context specific. To better understand the responsiveness of demand as a whole, sometimes it's easier to consider our own behavior as a consumer. If we're thinking about a product that takes no time to adjust your consumption to, so for example, if you're in the shop and the price of your usual toothpaste has increased, you can instantaneously choose to pick up the toothpaste that is cheaper next to it. Whereas if you were considering your phone bill, the time it takes you to make that decision will change the elasticity. If you have inertia, the elasticity is likely to be inelastic. It might take you several weeks to actually take the time to phone up your telephone provider and negotiate a new bill or change providers. Another way to consider the factor of time would be, is the question asking you over the short run or the long run? Are we thinking about an instantaneous change, or are they asking for the PED over a significant amount of time when there are no fixed factors of production? Get ready to pause the video. What is the PED likely to be for these items on the screen? Okay, hopefully you thought about all the different factors for each product, but I'm going to whiz through very quickly the key ones. So our first product on there are crisps or chips if you're in America. If we're thinking a brand specific type, we're going to have lots of substitutes, and so crisps are likely to have an elastic PED. Number two was an EpiPen. An EpiPen is a life-saving piece of medical equipment for people with nut allergies. And so for their target market, it is an absolute necessity, and it's likely to have an inelastic demand. Three is a sports car. So that is both a luxury and it is a large proportion of income. So it's likely to have an elastic demand. Four is vapes. Vapes are incredibly addictive, and so they are likely to have an inelastic demand. Five is water. Now, if you thought about this as just water, obviously that is a necessity, and so it would be inelastic. However, if we think about water as in water bottles that you can get in a plastic bottle for convenience, that's probably going to be elastic because there are lots of different brands and so lots of substitutes, and also you could bring water from home. Number six is paper clips. They are likely to have a very inelastic demand because they are such a small proportion of income. We're thinking about proportionality here. So if the price of paper clips doubled, that might just be going from a couple of pennies per paperclip to 4 pennies per paperclip. That's a 100% increase in price, but that does not necessarily mean it's going to have a proportional response. So less than proportional response means it's going to have an inelastic PED. And finally, we've got petrol or gas in America. It's definitely a necessity for most households. They have to drive to work. There are no substitutes to gas or petrol in the short run. Obviously, if we're thinking about time, it takes a long time for consumers to be able to switch their consumption from gas or petrol, because before they're able to do that, they'd have to buy a new vehicle. And therefore, gas or petrol is likely to have a very inelastic demand, which we're going to look at in the next example. So here we have the inelastic demand for petrol. I'm going to start at price 100 pence, which is £1, and we're going to have a quantity of 310 million units, as you can see on our x-axis. If we see an increase in price up to 120 pence or £1.20, we're going to see a contraction along demand and a fall in quantity demanded to 300. We can see that the increase in price as a percentage is going to be 20%, going from 100 pennies to 120, whereas the percentage change in quantity is a fall of only approximately 3.2%. And so we can say the change in quantity is less than proportional than the change in price. And so we can see we've got an inelastic demand curve. Make sure you've written down the definition. A good has an inelastic PED if the change in quantity demanded is less than proportional than the change in price. Also make sure you've written down the calculation. You work out PED by finding the percentage change in quantity demanded and divide it by the percentage change in price. If the absolute value of PED is less than 1, you have an inelastic demand curve. We know that total revenue is price times quantity, which can be represented by the area of the rectangle on the screen now. When price increases for a good with an inelastic PED, we can see that the loss in total revenue is much less than the gain in total revenue. So overall, total revenue will increase. It is so important that you consolidate your notes. So pause here and make sure you can fill in this grid with what you've learned so far. Here is me filling in the grid on double speed just to make sure you've got your notes down. So if I'm drawing a relatively elastic demand curve, I've drawn that as quite flat. My definition is the reaction in quantity demand is more than proportional than the change in price. PED is greater than 1 if I've got an elastic curve. The theoretical demand for perfect elasticity is a completely horizontal demand curve. And to calculate the PED value, I would find the percentage change in quantity demand divided by the percentage change in price. If I'm looking at the inelastic demand, I've got a quite steep curve drawn on there. My PED inelastic definition is the reaction in quantity demand is less than proportional than the change in price. To find the inequality, it's the PED is less than 1, and the perfect inelastic curve is completely vertical. And to find that value, I would do the percentage change in quantity demanded divided by the percentage change in price. It is also so important that you memorize the impact on total revenue. So if we have an elastic good and the price went up, we'd see a more than proportional fall in quantity demand, and so there'd be a fall in total revenue, and vice versa. If we had an elastic good and we saw a fall in price, we'd see a more than proportional increase in quantity demand, and so we'd see an increase in total revenue. For an inelastic curve now, if we saw an increase in price, we'd see a less than proportional change in quantity demand, and so we'd see an increase in total revenue, and vice versa. If we saw a fall in price for an inelastic good, we'd see a less than proportional increase in quantity demanded, and therefore we'd have a fall in total revenue. Having these memorized is the key to being able to spot these questions in the exam. One final term that you need to learn for the exam is unit elastic or unit elasticity. That's when the PED is exactly equal to 1. That means that there's going to be no change in total revenue as price changes. So you can see that if I draw on price 1, I get quantity 1. If there's a fall to price 2, I see an increase in quantity to Q2, but the area of those two rectangles is identical. Similarly, if price falls again to P3, I'm going to see an increase in quantity to Q3, but again, the area of that rectangle is the same, and so there is no change in total revenue. You have made it to the final question, and it is now your turn to answer this multiple choice question. If you want an extension, explain the answer in full sentences and use 2 diagrams drawn with a ruler. If British Airways found that the PED for business flights were negative 0.8, but that the PED for short haul flights to typical holiday destinations had a PED of negative 1.78, what could you deduce? Pause here and have a go answering the question. I'm going to dive straight into the answer. So the information in the question told us that the PED for business flights was negative 0.8. Now we know the absolute value of PED is less than 1 for inelastic goods. So we can draw ourselves a sketch using a ruler of an inelastic demand curve. And we can see that if price increased from P1 to P2, the change in quantity demand would be less than proportional. And so they would see an increase in total revenue. Whereas for the holidaymakers, it said that the PED was negative 1.78. Well, we know that if the absolute value of PED is greater than 1, then the demand curve is likely to be elastic. We can see that if the price fell from P1 to P2, there would be a greater than proportional change in quantity demanded, and so they would see an increase in total revenue. So if you were a consultant or an advisor to British Airways, you would suggest to them that they should raise their prices for their inelastic business flights and reduce their prices for their elastic holiday maker flights, and that would increase their total revenue. A further extension, you could ask yourself, why are business flights likely to be inelastic? Think through your SPLAT factors. A business flight will be bought by a business. It is usually a necessity for the function of the business. There are very few substitutes to try and get a colleague to a different country, and it will be a very small proportion of income for a firm. Whereas a holiday for a family is likely a luxury. There are lots of substitutes. You could stay in the country that you live in, and it will be a large proportion of the family's budget. And so that is why business flights are likely to be inelastic and holiday flights are likely to be elastic. I really hope this lesson has been helpful to you. If it has been helpful, please drop a like. It means the world to me. And if your teacher is interested in these resources, they'll be available to download soon.